Okay, so in this class, we're going to talk about systems for information management and just give you an understanding of the many different types of management information systems, or MISs, that exist in business. So this is usually a good primer to a lot of the different technologies that you'll see in business. So let's proceed to the first slide. So why learn about some of these systems? Well, because many of them are somehow linked to better serving current and future customers, right? I mean, there's always a customer connection between the system that exists in business and the function it provides, from an accounting system, from a system related to human resources, which are all part of what we'll talk about with respect to enterprise resource planning systems. They're all there to serve a customer, and they're ultimately there to serve the end user, the person who might use products that a company provides. But then there's also differing levels of customer, right? That customer can be an employee, that customer can be management, things like that. So there's different types of customers. So it's good to perceive them as customers, so that you as potential technologists, or people going into business or whatever, you understand that you have customers in multiple dimensions. So these different types of information MISs, assist with these different business functions, and that's what they're ultimately there to do, is improve service to the customer. So we need to also understand the practices in business that these systems serve to enable. And so what we'll do is we'll first talk about transaction processing systems to kind of give you an understanding of the nuts and bolts of making data consistent in an organization with some of these other systems we'll talk about. And then we'll go and we'll talk about the many different types of management information systems. So let's move on to the next slide here and talk about transaction processing. And I apologize for this being a bit of a crowded slide, but there's a lot to understand with respect to transaction processing. So what this basically is the processing of information, of data, into discrete, individual, and indivisible operations. So it's operations that can't be divided into anything else. And we refer to these as transactions. And so the big reason we need this is to have data integrity with respect to the system. So this links together a bunch of very discrete transactions to ensure either all operations are in a transaction are completed without error, or none of them are. So either everything happens, everything goes through, or it rolls it back to its state before the transaction intended to take place. So if some of the operations are completed but errors occur when others are attempted, the transaction processing system uses a rollback mechanism to roll back all of the operations of the transaction, including even the successful ones, thereby erasing all traces of the transaction, restoring the system to its the last known state that it was consistent before processing before the transaction began. So it's effectively, there's different levels of operations, and there can be a string of very discrete transactions, but for it to take place, to be successful or unsuccessful to a user, it could very well be more than one transaction. So they have to be, either all go through or none go through. And if one's unsuccessful but others aren't with respect to the transaction as it reflects the overall state, the even the successful transactions have to be rolled back to the last known consistent state. So, on the other hand, if all operations in a transaction are completed successfully, the transaction's committed by the system, and all changes to the database are made permanent. So the transaction cannot be rolled back once this is done. Think about how this can work with respect to your banking transactions. I mean, that's effectively kind of the most pertinent example to what happens in our everyday lives. You think about it with respect to ATM withdrawals, um, you know, checking, savings, debit card transactions, multiple people accessing the same account. Think about it with respect to that, and it'll make sense. So the acronym that's normally used with respect to transaction processing is ACID, ACID. So, the first letter in the acronym is atomicity. So all transaction state changes are atomic, so either all or none can happen. And then there's C, consistency, where a transaction must be a correct transformation of state. Isolation, where even though transactions execute concurrently, it appears that each transaction T that others executed before T or after T, but not both. So what that basically means is that transactions will happen in parallel, in somewhat of parallel, but the way time slicing in computing occurs, because transactions are able to process so fast, state changes are mutually exclusive. So they do happen in a very isolated fashion. So they happen by themselves, but because time slicing is so fast in computers to kind of the naked eye or our brains, it'll look like it's happening in parallel. So the last letter in the acronym, D, durability. So once a transaction completes successfully, whether there's a commit, it changes to the state, must survive failures. So let's say a transaction completes successfully and then the power goes off and the backup generators don't work, so the system goes down. Well, those changes have to be committed to non-volatile memory. So memory, if we remember that term, memory that persists even when power goes off. That's a good example of durability. So ACID, atomicity, consistency, isolation, durability. You want to remember that ACID acronym and what that means and relate it to examples that happen in your everyday life, for example, a bank account. And then you also want to remember the terms commit and rollback with respect to transaction processing. So it's important to know about that stuff, and how data works to be consistent in these big enterprise level systems. So let's go on to the next slide and talk a little bit more about transaction processing. So consider the following example. I talked about banks, right? A typical banking transaction that involves moving $700 from a customer savings to a customer checking account. So the transaction involves two separate operations, right? So in computer terms, it requires debiting the savings account by $700 and then crediting the checking account by $700 itself. So if one operation succeeds but the other does not, the books of the bank will not balance at the end of the day. So there has to be a way to ensure that either both operations succeed or fail, so that there is never any inconsistency in the bank's database as a whole. So you have these two transactions, and if one doesn't work, you have to, you have to roll back the entire operation. So let's move on to the next slide and talk about this a little bit more. So transaction processing systems, capture and process data for fundamental business transactions. It's really about those important transactions where data integrity, consistency, where that stuff is really important. That's where you have intense transaction processing. So it ensures databases are actively updated. And the first transaction processing system with this commit and rollback mechanisms was actually not from a bank. It was from the transaction processing system that American Airlines had, known as Sabre, which I think Sabre is now spun off into its own company. So at that time, Sabre was able to process a whopping 83,000 transactions in a given day. And this was for ticketing, of course. Whereas now, transaction processing systems have been adapted to entire transaction processing facilities, which are used by large banks, credit card companies, hotel chains, where 83,000 transactions can happen probably in a minute if you're thinking about bank debiting. Maybe less than a minute, maybe even in 20 seconds in a given region. Especially when you think about where we live. So The use transaction processing systems are proliferated throughout just about everything we do, especially when you talk about bank transactions, credit card transactions, and when you travel, for example. Um, so the figure you have below in this slide shows kind of where transaction processing sits with respect to other types of systems that we're going to talk about a bit in this lecture. So transaction processing systems sit right at the base, right at the data level or layer, below management information systems or decision support systems, which we'll talk about in this lecture. But it really sits at that base layer where you have things that are more routine with respect to transactions, less decision support type things take place at that level. It's really about fast input and output that happens more, and there's less sophistication and complexity of processing analysis at the transaction processing level, because it really does just what we've described in the previous slides. ACID, atomicity, consistency, isolation, durability, making sure those qualities are met, and then making sure that all transactions succeed or none of them do, and it's restored to a consistent state if none, or stored in a durable state if they do succeed. So let's move on to the next slide. Talk one more slide about transaction processing. The other things you want to know is that there's two different types of transaction processing. There's batch processing, data processing for when business transactions can happen at a certain time. They're accumulated over a larger period of time, and prepared for processing as a single unit or batch. So there can be a delay. There is or can be a delay between the event that created the necessity for the transaction and the processing of it. So then the next type we have is online transaction processing, or real-time transaction processing, where each transaction is processed as fast as computers allow, as soon as the event occurs. So data in an online transaction processing system should reflect a current status. So like I've said, it's used in banks, credit card transaction, Sabre, and any other type of e-commerce transaction that takes place. And increasingly, there's a growing connect between what you purchase online and the current balance in your bank account. There's even to this day a little bit of a delay. It's rare that if you buy something on Amazon and you have no money in your account, that it's not going to let you buy something on Amazon. What's more likely is that you'll get a notice from your bank that says that you've overdrawn, and you'll either be charged a fee or it'll come out of your savings depending on how you have that thing set up. So when you think about the differences between these two types of processing systems, think about, with respect to batch processing, how your paychecks are processed. Those still take place in batch manner. And then, of course, debit card transactions, credit or debit. That's more OLT or real time, OLTP or real time by nature. So this concludes our small section on transaction processing, and I spent a little bit more time on this because this is the base layer of how data is made consistent in some of the systems we'll talk about. So let's talk about some of those other systems. And let's talk globally about this notion of enterprise resource planning, which is the act of managing an enterprise's resources. And so that's a very generic term, but what it boils down to, with respect to resources, is product planning, cost, development, manufacturing, marketing, sales, inventory management, shipping and payment, and the associated human resources that are involved in these activities. So what I'm doing in these next several slides is I'm talking about the notion of what something like enterprise resource planning is, and then in the following slide I'm going to talk about the technology that enables this type of thing. Because at one point in time, this was all done by humans, right? And the practices are still quite similar. It's just that in philosophy, they're quite similar, but they've changed because we have technology that automates and speeds things up. So now let's talk about enterprise resource planning systems, where it provides an integrated and real-time view of a company's resources, a company's business processes. So it tracks your business resources such as cash on hand, raw materials, what your current production capacity is, the status of business commitments such as orders, purchase orders, payroll, etc. It's comprised when you think about it in terms of technologies, you know, it's really comprised of multiple applications, some of which we'll talk about today, that share data that is representative across multiple departments. So I'll give you an example of that. I've talked a lot about siloed technologies in business. Well, enterprise resource planning was meant to solve a lot of the data silos that existed in business. So make payroll an example. In the early 90s, late 80s, payroll was processed, if in a large corporation, payroll was processed by the accounts receivable in specific, departments or businesses within a corporation, or business units within a corporation. And the data for a customer, or I'm sorry, well, also a customer, but also your employee, the data for an employee, if they worked across multiple business units, would be duplicated. So then all that stuff got consolidated so that you didn't have duplicate data, an expensive resource to maintain large amounts of duplicate data. And that's what ERP did. And that's what enterprise resource planning systems did for businesses. And that's what it still continues to do, and continues to streamline business processes and give people the opportunity to re-architect business processes with respect to the technologies they now have, so that things can be more automated, faster, more efficient, etc., whatever the business needs. So it's comprised of multiple applications that do this, and it facilitates information flow between business functions, business units, departments, and reduces those data silos. And it can also be used to manage the flow between the business and outside stakeholders. What is sometimes great that a lot of companies do is give channel partners or external suppliers access to something like the inventory that they may have on hand, and then they have an automatic system. If they know they're always going to be using this inventory, well, then there's potentially an API, an application programming interface, that allows an external supplier to be able to query the current inventory on hand and furnish supply that that company needs based on the demand or how low the inventory's gotten. So some of the advantages of ERP systems. It gives you a complete visibility into all the important processes across various departments. It makes workflow more automatic and coherent from one department or business unit to another. It provides a unified and single reporting system, especially great for management to analyze the statistics, numbers, status, etc. in real time across functions, business units, departments, however a corporation may be organized. Since the same software, in general, is used across all departments, this avoids individual departments having to buy and maintain their own software systems. It also, reduces the expense of duplicate data and the amount of storage you need to be able to house that duplicate data. So certain ERP vendors can extend their ERP systems to provide other types of functionalities like business intelligence, which we're going to talk about in a later lecture with respect to big data. So you have all this data across, that's coherent across your corporation, consistent across your corporation. Why not analyze it to gain a little bit more intelligence as to what you need and when, what bottlenecks exist, what your supply chain looks like? Why not do more advanced analytics to be able to understand your corporation more, especially now that the ability to conduct these types of analytics is becoming increasingly less expensive than it was 10 years ago. I mean, it's gone down dramatically. So, business intelligence is now becoming a critical part of enterprise resource planning systems. So, like I've alluded to before, there's various modules or applications in an enterprise resource planning system: finance, accounting, human resource management, manufacturing, marketing, sales, supply chain, warehouse management, CRM, customer relationship management, project management, you name it. It's there's hundreds of different applications that exist under the auspices of an enterprise resource planning system. These are just a few listed here. So some of the difficulties, I've talked about the advantages, some of the difficulties related to ERP. Deploying systems of this magnitude, you have to imagine that it can be very, very difficult to do such a thing. So the first such disadvantage is the cost of ERP software: planning, customization, configuration, testing. A single monolithic type system is extremely expensive. So deployments historically have taken 1 to 3 years to get completed and fully functional. And this is still the case today. When I was working in industry just about a year and a half ago, I was part of the implementation of an enterprise resource planning system for the Navy, for the Pacific Southwest, or Navy Southwest region. And it took 3 years to get that thing up and running. So another disadvantage is too little customization. If you don't have the ability to customize, may not be able to really integrate the ERP system with the business processes. And too much customization can potentially slow down the project and make it difficult to upgrade. So many times, there's a lot of research in the information systems field about IS failures, and a lot of the IS failure research came from a lot of the ERP failures that we started witnessing in the 90s. And what a lot of the reasoning boiled down to was that people were just trying to implement the technology without customizing it and tailoring it properly with respect to the business. So it's tailoring it and then also really understanding the technology that you need versus trying to apply a blanket technology to the business. And so it made things, you could imagine applying such a blanket technology made things very, very costly and cost big corporations millions of dollars. So, some other difficulties related to ERP is the cost savings or payback, may not be realized or may not be able to be realized immediately after the ERP implementation, and it's very difficult to measure this. How do you know whether or not you've actually reaped the benefits of an ERP system if your customers are all internal? You have to be able to track these metrics and have them in the first place. Another difficulty is that ERP systems are both difficult and complex to achieve in organizations that are decentralized and have disparate business processes and systems. You have to change a bit of the organizational culture to make that happen. And like we've alluded to throughout this course, it's the behavioral aspects, it's the cultural changes, it's the infusing of technology with respect to the culture and the people in the business that's really difficult. The technology's there, the customizability is there, it's understanding what to implement and how to get people to adopt it that's really difficult. So we talk about that in my research a lot with respect to technology adoption and diffusing. Adopting the technology, getting organizations to adopt it, and then in small part, and then diffusing it throughout the rest of the organization. So ERP implementations are difficult to achieve in decentralized organizations like we talked about. And then also, once an ERP system is implemented, it could also become trouble because you're locked into a single vendor like SAP, for example. So further upgrades, customizations, become difficult and become expensive. and also your data is locked in. So one of the things you have to think about as somebody who implements technologies is, what's your exit strategy? How do you get out of this mess if it doesn't work out for you? You got to think about these things. So, this outlines some of the difficulties, some of the troubles with implementing an ERP system. It's not a panacea for the ills. It's something that has to be implemented with great respect for the culture and people and what's needed in the organization. So let's move on to the next slides and talk about some of the specific types of functions within ERP. So one of these is supply chain management, where it manages the movement and storage of raw materials, work in process inventory, and finished goods from the point of origin to a point of consumption. So interconnected or interlinked networks, channels, and node businesses are involved in the provision of products and services that are required by end users or end customers in a supply chain. So it's from internal to external. How do you supply goods and services to your customer? So the design, planning, execution, control, and monitoring of supply chain activities with the have the objective of creating that value and building competitive infrastructure to leverage things like worldwide logistics, synchronizing supply and demand, and measuring performance globally. So, this is a very complex process, and there's entire research fields devoted to supply chain management. One of them is operations research, and our decision sciences department does a lot of work in that area. So I'm just touching on it with respect to the systems perspective. But if you ever wanted to learn more about operations management, operations research, the decision sciences department and the folks over there are doing great work in these areas. So supply chain management addresses complex problems such as distribution network configuration, distribution strategy, knowing the trade-offs in logistical activities, sharing of information, managing inventory, and the cash flow. You have to be able to negotiate the supply and demand of parts to make your goods and services. So supply chain management systems are what enable the real-time movement of parts to product, going from parts to product. So some current trends in supply chain management systems are that wireless now accommodates a sharper focus on efficiency and transparency. It's integrated heavily with things like customer relationship management. Gives you access to real-time, accurate information, where customers are switching to more of a demand management style, where effectively you're able to fulfill the need for parts and services so quickly that when you have the demand, it can be responded to so fast that you can move from supply chain management to more of something like demand management. It's kind of crazy to think about. In that relates directly to this notion of just-in-time order fulfillment. It also, these types of systems also help with manufacturing flow management. How parts flow and become manufactured into actual goods, and ensuring that you have goods being produced in a consistent manner. It also, these types of systems stand to improve relationships with suppliers, and of course, with respect to product development and commercialization of such product, and hopefully streamline what you spend, what your costs are in goods and services, parts and services, so that you have a greater return on investment. So another such system within ERP is financial and managerial accounting. So I'm not going to go too much into this. You guys, there's probably finance and accounting majors in this class. There usually are. And you guys know a lot more about this than me. So I would be deferential to what you guys are learning and what you guys know in this perspective. But what I am trying to emphasize is that the notion of financial and managerial accounting with respect to financial accounting, tax accounting, managerial accounting, and the associated data, cost measurements, and things like that. This is a practice that's now under the auspices of enterprise resource planning. And so these financial and managerial accounting systems, do things like record financial processes into a comprehensive general ledger, which if you're accounting or finance, I'm sure you've learned about. I think everybody has to take an accounting class at some point. Um, supports multidimensional reporting and in parallel or different accounting standards. Integrates assets, payables, receivables, and inventory into a single system. Uses very powerful management accounting tools for orders, project cost centers, profit centers, and usually has rather comprehensive functionality for closing automation, reporting, and audit support. So it's very Sarbanes-Oxley compliant, tax compliant, links in with your tax reporting systems, your accounting systems and your tax reporting systems have to work hand in hand, because if you ever own a business, one of the things you have to understand is that uh, paying taxes, the IRS is structured as a pay-as-you-go system. So we pay as we go, as people on a yearly basis. But a lot of businesses will pay quarterly, so they don't have a big tax burden at the end of the year. I particularly did that when I owned my own business. I made it a point to pay quarterly because I saw the pitfall of potentially having a big tax burden at the end of the year. So let's talk about some other systems. Let's talk about customer relationship management. So the act of customer relationship management, or the practice, is simply how a company manages its current and future interactions with customers. So sometimes this happens with small-time technology, just a simple Excel spreadsheet, but usually involves the following departments: sales, marketing, customer service, and technical support. So it can be small. You can see our customer relationship management. The practice can be in small scale if you're a small business or a small department, or it can be in larger scale, right? And you can have customer relationship management systems that automate and integrate these functions of sales, marketing, customer service, technical support, things like that. Um, there's a lot of products that we see out in the working world that do a lot of stuff with CRM. Salesforce was the first cloud-based CRM provider and continue to be probably the dominant player in CRM these days. And then there's also a lot of open source tools such as Sugar CRM, which you can download for free and use. And there's probably some other cloud-based service. I think NetSuite does CRM. I know that a lot of the financial and managerial accounting stuff with respect to Intuit and their cloud-based tools offer CRM functions. Probably not what you would be looking for if you worked in a large organization, but it does offer some customer functionality. But the key features of a CRM is automated contact management, sales management, customer support, marketing automation functions, for campaigns and things like that, data analysis about your customers, integration with social networking, integration with mobile device access. If you're a salesperson, you're out in the field, you want a mobile app that allows you to input information about your customers, about contacts, and then allows you to import customer data, from other places, so you have it all in one place. So this CRM graphic I have kind of gives you the big four, right? Marketing, sales, orders, and support. As in terms of functionality, and those are the big four with respect to CRM systems and the functions they provide. You can see there as well. So going to the next slide, another function that can happen within the auspices of ERP or just with respect to management information systems is the notion of decision support. So, if implemented properly, IS information systems can make businesses more efficient and effective with respect to using stuff like database systems, cloud computing, internet, e-commerce, enterprise systems. You get the idea. But from a business perspective, this information, this consolidated information, this analyzed information, there's also real potential in having systems that can help you make more informed decisions when you do these analysis. So you give people tools to analyze and capitulate data into a form that helps people make decisions. And so decision making is a very important component of problem solving, of the overall steps to solving a problem, and there's lots of tools that can help you do this. So what I have here is a graphic that shows, this comes from some very academic stuff, but I think it's helpful to understand the different steps in solving a problem, right? So intelligence, having intelligence about a problem, designing different solutions, or choosing those problems, making a choice, implementing what you've chosen, and then monitoring and analyzing to know, cerebrally or through technology, whether or not what you've done is something that's provided value. So intelligence, design, choice, implementation, and monitoring. And we can use technology to help us, actually do decision support, to go through these steps, to analyze data, to help us make choices, to implement those choices and monitor the effects of those choices. So with respect to decision-making types, there's two types of decision-making types, overall. And, it's very possible that if you talk to someone in decision sciences, they're way smarter about this than me. They may have a completely different view of this. But in general, there's two types of decision-making types. There's programmed and non-programmed decisions, where programmed decisions entail a decision made using a rule, a procedure, or a quantitative method. And so a programmed decision is something that's very discrete. It's if you take in statistics, it's a regression equation. That's a great example of a programmed decision. Or other type of quantitative method where you have kind of hard numbers as output to help you make a decision. And then there's this notion of non-programmed decisions where things are a little more fuzzy, complex, but we still have to make decisions in these environments. So a non-programmed decision is a decision that deals with unusual or exceptional situations that can be difficult to quantify. And this uses different types of algorithms that are less specific. So there's optimization algorithms, satisficing algorithms, and different heuristic approaches, which basically give you rules of thumb to make decisions. So some examples of this is, determining the appropriate training system for a new employee, right? That's a programmed decision. But then deciding whether to develop a new type of product line, well, that's a non-programmed decision. That's a case where technology and computation can help you get to some reasoning for different alternatives, but can't help you make the decision. And then there's another example, weighing the benefits and drawbacks of installing an upgraded, pollution control system, for example, right? So you have to know the benefits and the drawbacks, and you're only going to be able to look at data that's very crude in comparison and have to derive some sort of decision as to whether or not, this type of environmental control system is actually going to provide value. So let's take a little bit more of a look at these optimization, satisficing, and heuristic approaches. So, an optimization model is just a process to help you find the best solution. And usually the one that will best help the organization meet its goals. But, it's difficult to have the correct data for these types of things. So you have to look at different optimization models. A satisficing model is similar. It's something that will find a good but not necessarily the best problem solution. And then a heuristic is, I like to think of the analogy of a heuristic being like rules of thumb or a rule of thumb, where it's just a commonly accepted guideline or procedure that usually helps you find a good solution. So now that we've talked about these different types of programmed and non-programmed decisions and decision support in general, let's look at different types of decision support systems, right? So it's basically a tool to facilitate organizational processes, the technology to help you do that. So any system that is consistently used to help organizational decision making can be considered a decision support system. And it tends to be aimed at these ill-structured, underspecified, or wicked problems, I've used that term before in this class, that upper level managers typically face, right? It combines the use of things like models or analytic techniques with traditional data access and retrieval functions. And it contains features that make them easy to use by non-computer people in an interactive mode, right? So some applications for this. There's clinical decision support systems for medical diagnosis, credit loan application verification, right? They don't tell you, when you talk about verification of a loan application, it's usually not hard numbers, but it's something that helps you, make a decision. Different types of competitive analysis with, maybe even doing different types of SWOT analysis using advanced analytical techniques, executive dashboards, and then, a more specific example with respect to yearly agricultural production. What should you be doing next? What's the next best thing to produce on your farmland, right? These days, it's interesting. I read an article not too long ago about this. Is that big data and agriculture are hand in hand, and people are using all sorts of advanced analytics to do farming these days and to do predictive farming. So let's go on to the next slide and talk about a different type of system, but related to decision support and MIS in general, and that's the notion of knowledge management. So, knowledge management is the process of capturing, developing, and effectively using organizational knowledge. Answering the question of how do we take the, specific expertise of what we have in an organization and harness that for competitive advantage. And that is a very, very wicked problem. But there's things that people use to try and manage this knowledge. A very basic form of knowledge management with respect to technology is a code repository, right? Having all your code in a single repository so that it can be analyzed is a very rudimentary kind of knowledge management. But in general, some of the motivations behind knowledge management is, making available increased knowledge content in the development and provision of products and services, achieving shorter and new product development cycles, facilitating and managing innovation and organizational learning. If you want to learn about something that someone's doing, for having starter material, you always need to talk to the person, but having material so that the job functions are commonly understood is huge. So you want to be leveraging the expertise for competitive advantage of people across the organization. You also, knowledge management also serves to increase kind of the network connectivity between internal and external individuals with respect to a business function. It also, another motivation is managing business environments and allowing employees to obtain relevant insights and ideas appropriate to their work. So, leveraging the knowledge of others to help generate ideas. Again, solving intractable or wicked problems, leveraging the knowledge of others to help solve difficult things. And then another motivation, the last one I have here, is managing what I refer to as intellectual capital, the expertise that people have that helps the organization thrive, these assets in the workforce, such as know-how possessed by key individuals, and leveraging them for strategic advantage. So knowledge management is really, comprised of a number of different things. And it's the spiral of socialization, or I guess it would begin at internalization, socialization, externalization, and combining that. And then continuously learning by doing, building the field or the team with respect to that knowledge, having a dialogue about the knowledge, and linking, now that this implicit knowledge has been made explicit, it's been codified to some degree, linking this explicit knowledge together. So with respect to that philosophy, there's this notion of tacit and explicit knowledge, or explicit and tacit knowledge. So explicit knowledge, and you want to know the difference between the two. Explicit is knowledge that's objective, right? It can be measured and documented in reports, papers, and rules. Tacit knowledge is something that's hard to measure and document. It's something that's typically not objective, formalized. And many organizations attempt to convert tacit to explicit knowledge using knowledge management processes and systems. And this is very difficult. Converting tacit knowledge to explicit knowledge is very, very difficult. I do it every day as someone who's attempting to publish my research. I have something that's very tacit to me, and I'm trying to make it more explicit and put it into the scholarly community. And this happens in business functions as well, where you have people who have an explicit knowledge, such as someone who understands image processing very, very well, or image editing very well. And other people want to learn about it, and they want to have more people doing it. But there's this one expert who really understands how to do it, and to really make it something advantageous to the organization. Taking that knowledge that's tacit to that individual and making it explicit so that others can do it is critical to knowledge management in an organization, and also critical to the diversification of resources. I've probably used this example at some point in class, but what if you have somebody who knows something really well and nobody else knows how to do what they know how to do, and that person gets hit by a truck? Well, your organization, if nobody else knows how to do it, is at a severe disadvantage. If you've taken steps to manage knowledge, then then it's something that's a little bit easier to make the transition from one person to the next. So let's talk about data and knowledge management workers and communities of practice. So data workers, are secretaries, administrative assistants, bookkeepers, data entry people, etc. And then you have people who are more considered knowledge workers. And now, in the past 10, 15, 20 years, the amount of knowledge workers in an organization has quite literally skyrocketed. People who create, use, and disseminate knowledge, such as professionals in science, engineering, business, writers, researchers, educators, corporate designers, etc. These types of people in our information economy have exploded. And so now, they have not themselves exploded, but the quantity of them in the workforce has exploded. And so it's created the need for things like a chief knowledge architecture, who's the top-level executive who helps the organization use knowledge management systems to create, store, and use knowledge to help achieve organizational goals and realize some strategic advantage. So there's also, within organizations, there's general communities of practice where people are dedicated to a common discipline or practice, where it's more than one person doing that particular thing. So there's knowledge transition that can be used to create, store, and share knowledge. And creating these communities of practice, even in small organizations, is really, really important. Not just for the hitting the truck scenario, but getting people together to talk about their practice to help do it better and to evolve their practice and what they do. So we've talked a lot about knowledge management and the different types of knowledge. Now let's discuss the technology that helps enable this types of stuff. So all types of technology that supports the retention and harnessing of knowledge is a knowledge management system. I use the code repository example as a very rudimentary example. Definitely can be considered a knowledge management system. So knowledge repositories, things for documents, reports, code even, files, databases. There's also, as you move up one level, there's knowledge maps, which point the knowledge worker to that needed knowledge, the ability to know where that knowledge lies. And then we move up the scale, up the ladder a little bit again and talk about how this knowledge is analyzed. So knowledge management systems with respect to data mining and business intelligence, analyzing the knowledge you have to help capture and use it for competitive advantage. So anything that allows an organization to capture, search, even analyze can be considered KM technology. And effective knowledge management systems are based on learning new knowledge and changing the approaches and procedures that you have in an organization as a result of that understanding. So having something with respect to knowledge management systems that can actually allow an organization to take action is critical. for an effective knowledge management system. So the graphic I have below, you have creation, you create knowledge, you store it, you convert it from being tacit to explicit, and then you share it, and then actually use it to do something with it. So this is, kind of is the end of our understanding of, kind of the more core enterprise resource planning systems and management information systems that I'm talking about in this lecture. And so now as we move on to the next slide, I'm just going to briefly talk about some of the other types of management information systems that we have. So all that we've talked about can be considered an MIS. Even ERPs are MISs. Supply chain management systems or management information systems. They all kind of fall under this big global umbrella. A lot of them are, is considered part of ERP, and there's also many more that I haven't talked about, that are MISs and even applications in an ERP. So I guess the way to think about it is MIS is the huge umbrella. An ERP is a type of MIS, and then there's many different applications that can exist under the auspices of an MIS. So manufacturing MIS, can be part of supply chain management, can be something different. A marketing MIS can be part of CRM, can be something different. Human resource can be part of an ERP, could be something different. Financial, again, accounting can be both of those could be part of an ERP or something completely separate from an ERP, from what an organization might consider part of their ERP. Then you have geographic information systems, which link all the data you have to geospatial data. You have expert support systems, which help with really complex or wicked problems. You have group support systems, which are specifically tailored to communities of practice or working within groups. And then you have group decision support systems, which allow people in these communities of practice to do data analysis to help them make decisions. So there's many, many different types, and tons that I haven't even mentioned. And so, in conclusion, moving to our second to last slide, in this lecture, what I've tried to do is I've tried to help you learn about the many different types of information systems, of management information systems, ERP systems, and then an understanding of what the different types of applications for supply chain management, marketing, CRM, financial, managerial, other types of things that you will encounter in the workplace. So these systems can exist rather holistically in the way we've talked about, or can be split up in part of a larger cloud-based system even, right? Your financial can be in the cloud while you could have an internal ERP for human resource and payroll management, for example. And so it really all begins with data and having accurate data. And that was why I spent a bunch of time talking about transaction processing. And then it ends with a system that's intended to better serve the needs of the organization, of a customer, internally or externally, and provide some strategic advantage or give an organization better competitive advantage with the technology that helps enable the processes and the functions in business that we talked about. And so hopefully I've helped clue you guys in to the many different types of systems and practices that that these systems help enable, that you'll see in organizations, in the businesses that you guys go out and work in. And also hopefully that you'll say, hey, what is a CRM? What do these things do? So you research it a little bit more. What is a marketing management information system? So you go out and you research it a little bit more. What is a financial MIS? So you go out and research it a little bit more. What types of systems people are actually using. I could name a lot of these systems, over the course of the lecture, but I've specifically chosen not to because these things change rapidly. Just know the general functions of the technology and then look and see what people are using to help enable them to do financial, managerial, accounting, customer relationship management, human resource management, payroll, things like that. Hopefully this helps you understand these many types of systems you'll see, and even facilitates you doing some additional research to understand some of these systems that people use. The IS department, we use SAP a lot in some of our we use SAP a lot in some of our courses, and also offer an SAP certification, which is a type of enterprise resource planning system, and also does a lot of analytics and business intelligence. So we point to that technology as being a dominant player and help students know how to use it. So if you're interested, definitely talk to me about it. And we'll be doing this for several more years. So hopefully this presentation has helped you understand these many types of systems and the many different purposes that these systems actually serve to enable. So I don't know how to pronounce that in French without butchering it, but I just wanted to put it up there. So until next time, I will see you next week. Have a good week, and hopefully you get a chance to review all of the materials and come prepared for class.